So hello everyone, I am Mohammad Isaf and I hope everybody is doing good. So today let us solve worksheet number 11. Okay, from the TS government provided worksheets SCERT, from the site SCERT, we are going to solve worksheet number 11. So firstly, the first question is the difference between speed and velocity. Okay, the difference between speed and velocity. So first point is the distance traveled by a body in a unit time is called speed. Okay, the distance traveled by a body in unit time is known as speed, but no direction. Okay, here in speed we have no direction, only we are considering the distance covered in the given time. Okay, now in the velocity, distance traveled by a body in a given direction. Okay, we have to consider the direction. Okay, here it is nothing but a displacement. We have to consider direction. Okay, this is the velocity, distance traveled by a body in a given direction. As we all know that speed is a scalar quantity, it has no direction. Velocity is a vector quantity, we have a direction here. So the speed, the value of the speed can be positive or 0. Okay, the value of speed can be a positive one or can be 0, but never be negative. Okay, no negative values in the speed. Whereas in velocity, it could be positive, negative, as well as it can be a 0 one. Okay, as well as it can be a 0 value. Okay, so the formula for speed is distance by time, total distance by time taken. So simply the units are meter per second. Distance meters, time seconds. Okay, so similarly for velocity we have displacement per time, and the units are meter per second as well. Okay, meter per second. So this is about the differences between speed and velocity. Now we will see the second question. Here the question is the initial reading of the odometer, the distance recording. Okay, in the cars and vehicles we have the initial reading of the odometer is 25530. Okay, 25530. After 6 hours journey, the odometer reading changes to 25860. Okay, from initial point it is changing, which means the car or a vehicle is covering certain distance. Okay, certain distance. Now we have to find the average speed. So to know the distance, what we have to do, this is the initial distance and this is the final distance. Okay, actually the initial reading and final reading, you can say initial reading and final reading. So we have to know what is the exact distance you have covered. So we will minus this, so we will get as 330 is the answer. Okay, if we minus these two terms, we will get 330. Okay, we will get 330. Now we have distance in terms of kilometer. Okay, we have 330 kilometers and we have time as 6 hours. Okay, so distance by time is a formula for speed. Right, so distance is equals to 330 and time is 6 hours. If we cancel them, we will get answer as 55 kilometer per hour. Okay, so this is the speed. 55 kilometer per hour is the speed. Okay, understood. So now let's see question number 4. So the bus travels a total distance of 225 kilometers in 5 hours. Find the average speed, he says. Okay, so distance he has given and time he has given. So distance divided by time will get speed. Okay, so distance is 225 divided by 5 hours. we'll get it as 45. If we cancel them, we'll get 45 kilometer per hour. Okay, 45 kilometer per hour. Now the next question number 5 is more or greater speed. In which of this figure, okay, this is figure A, B, C and D, which has more or greater speed. Okay, so let us see. This is taking some time, also it is covering some distance. Okay, this is covering a large distance in less time. Large distance in less time. This is distance over here and this is time. Okay, here it is distance and here it is time in the graph. Okay, similar way is taking too much time but covering less amount of distance. Similar way is taking too much time but covering less amount of distance. So answer is B. This figure is correct. Okay, I'll draw it again here. This figure is correct. This is correct. It has more speed. Okay, it has more speed. So now next question is which is the vector quantity, and the options are speed, acceleration, something like that in this. So the answer is the velocity. Okay, the velocity is the vector quantity. Velocity is the vector quantity. Now the next question, question number 7 is the tangent drawn on the curved path represents magnitude of speed. Represents magnitude of speed. So now let us see question number 3. Okay, the question number 3 is the ball is thrown horizontally from a point A. Okay, it says that from point A a ball is thrown. Okay, a ball is thrown upwards, travels along this straight line and strikes the ball. Okay, so it is saying that the ball is traveling in straight line and striking the ball at particular point, and the distance of this ball is given as the part, and which is distance of 10 meters. Okay, the distance between the ground and the ball is given as 10 meters. This is the distance. Okay, this is the distance. Distance is represented by S. So distance is given. After striking, the ball is bouncing back. Okay, it is getting back to original position. Okay, to original position. So now he is asking to find the average speed or average velocity. Okay, average speed is asking an average velocity. So we know that the formula for average speed is distance by time. Okay, so how much distance is covering? 10 upwards and 10 downwards. 10 plus 10, 20. Okay, we have to consider whole distance. After striking, it is getting back into original position. So 10 plus 10, 20. 10 plus 10. 10 plus 10 and time. What time he takes? He says 8 seconds. 8 seconds. Okay. To same A is 8 seconds. 8 seconds. 20 divided by 8. We'll get the answer. We'll get the answer. Speed. We'll get the speed. Similarly, for velocity, we have displacement. Displacement by time. Okay, displacement by time. So displacement, the shortest distance between A and B. Let us consider this point as B. So this is 10 meters. So we need not to consider the whole distance. We are considering only the displacement, the shortest distance. So it is 10. So 10 by 8. 10 by 8 is the velocity. So it is given as meter per second. Meter per second. Okay, meter per second. So this is about the question worksheet 11. Okay. Now let us see the worksheet number 12. Worksheet number 12. See, in the worksheet number 12, the first question is the student can run 100-meter distance in 8 seconds. Okay. So he says in the first question, the student A can run 100 meters in 8 seconds. he has to find the speed. Okay, so we know that speed is equals to distance by time. So distance is 100 divided by 8. So we'll get it as 12.5 meter per second. Okay, we'll get it as 12.5 meter per second. So now the second question is, if the velocity of the student is 8 meter per second. So he is directly given the velocity. Velocity is 8 meter per second, and he says he is asking to find the displacement. He is asking to find the displacement when time is given as 8 seconds. Time is given as 8 seconds. So we have the formula for velocity as displacement by time. Okay. So here we have velocity 8 is equals to, we don't have displacement. Okay. Displacement, I'll write it as same displacement, and time is 8. So we need to multiply these two terms to get the displacement. So displacement is equals to 8 into 8 is equals to 64. Okay, so displacement for this is 64. So now we have another question number 3. In question number 3, he says a student A travels 75 meters in 15 seconds. So student A is traveling 75 meters in 15 seconds. Okay, 75 meters in 15 seconds. And student B travels 80 meters in 20 seconds. 80 meters in 20 seconds. So now he is asking who is traveling faster, whether it is student A or B. So let us see this. Okay, so for speed we have a formula distance by time. So I am calculating for student A. So 75 divided by 15. 75 divided by 15. So I'll get it as, okay, so I'll get it as 5. Okay, I'll get the answer as 5. And now similarly for student B, if I calculate, the distance is 80 and the time is 20. So it is 4. So here meter per second is the units. Here also meter per second are the units. So who is traveling faster? Student A is traveling faster. 5 meter per second. Okay, so student A is traveling faster. Now let us see question number 4. Question number 4. A cheetah can run 100 meters in 4 seconds. He says cheetah can run 100 meters in 4 seconds. Okay, 4 seconds. Find the distance covered by it and 10 seconds. Okay, so now he is asking to find the distance covered by cheetah in 10 seconds. So let us form this. So distance by time. Okay, for first phase I wrote distance by time. Similarly, we don't know the distance here. We need to calculate the distance by time 10 seconds. Okay, so cross multiply these terms. So we'll have 100 into 10 100 into 10 is equals to 4 into distance. 4 into distance. So we'll get it as 1000 into 4 distance. 4 into distance. So this 4, I'll just move it over here. So 1000 divided by 4, we'll get distance. So we can represent that as so. So S is equals to 250. 250 meter per second. 250 meter per second. This is the answer. So I hope it is clear. Worksheet number 11 and worksheet number 12. Thank you.